Aubrey de Grey thinks of himself as a modern-day Methuselah. He has dedicated his career to fighting aging. Aubrey believes that many people who are born today could live to be 1,000 years old and remain physically young for most of that time. The key is a matter of good biological housekeeping, taking the trash out of our cells.
So what happens indeed is that certain types of material in the body just accumulate junk. Certain types of junk accumulate inside cells and between cells, and stuff that we would not think of as junk, like DNA, accumulates randomness, which is a type of junk.
Cells have the important job of constantly breaking down waste, and they're mostly pretty good at it. But sometimes a cell comes across things that are so weird, none of its degradation machinery works on them. That's when the junk is rerouted to what's called the lysosome, the vessel that houses the most powerful degradation machinery in the cell. And if the garbage can't be broken down, it stays there forever. Aubrey believes that the accumulation of garbage in the lysosomal storage unit is what causes aging, and he wants to free our bodies of these buildups. He realized the most logical way was to take a close look at waste itself, and he wondered, in nature, what likes to eat junk?
We're working on an idea that we might be able to find other species, especially bacteria, that are able to break down the substances that accumulate in the human body.
Aubrey's hunt for the fountain of youth led him to a final resting place: graveyards. Since graveyards are riddled with the waste of decomposing bodies, he suspected he might find microbes who live to feast on death.
And if we can find the genes and enzymes that they are using to actually perform that function, then we might be able to put those genes and enzymes into our own cells so that our own cells can break stuff down that they could not naturally break down.
The secret to longevity might be 6 feet under. Aubrey and his team are still digging for the right microbe that will work in mammalian cells. And when they find it, he believes we will all live like 25-year-olds forever.
I think that we have maybe a 50-50 chance in the next 25 years or so of developing what I think of as the first generation of bona fide rejuvenation biotechnology. In other words, technologies that are sufficiently comprehensive that we can give them to middle-aged people 60 or 70 or so, and fix them up well enough that they don't become biologically 60 or 70 again until 30 years later or something like that.
Aubrey is looking for the magic bullet that will fight aging, but synthetic biologist Chris Voigt is looking to build an entire army out of various parts from all over nature.
All right, let's give this a shot. What we're often trying to do in synthetic biology is create new functions out of parts that already exist in nature for other reasons. So we're often having to go out and grab those components from different organisms and put them together.
Chris searches for microorganisms throughout biology to find the right parts. And they end up at his lab at the University of California, San Francisco, where biology meets mechanics.
When you look at being able to fight disease, whether it's identifying malignant cells and killing them, we're trying to go through the garbage of all the functions that are out in the natural world and identify those that are useful to us in trying to be able to identify and correct a disease state in the body.
To build a biorobot that can detect its surroundings, Chris and his team needed to find an organism with a sensor. And they found it in pond scum, where they discovered that algae are equipped with light sensors.
We took a bacterium that normally lives in your gut, so it's not used to the sun shining, and we put in a light sensor out of an algae.
Inside Chris's bacterial darkroom, colonies of bacteria that are now implanted with algae light sensors are able to take photographs of slide-projected images. It might look like bacterial art, but this is the first big step towards creating programmable biological robots that will keep our bodies healthy forever.
There are bacteria all throughout our bodies, and we can reprogram those bacteria in order to be able to implement therapeutic effects for just about any disease that you can imagine. The possibilities are limitless.
Chris's photographic bacteria are able to turn themselves on and off like the flip of a switch. But the question is, can Chris figure out how to program and control that switch?
We'd like to see the programming of cells to be the same as programming a computer or designing an electronic chip, where as programmers we would write out the exact function that we'd want the cells to do, and then that would be automatically compiled into a DNA sequence in the same way that a computer program gets compiled ultimately into ones and zeros. That's the dream.
Biorobots may one day roam our bloodstreams, police our organs, and respond to our internal 911 calls, keeping us free from the threat of disease. Chris Voigt's and Aubrey de Grey's research to keep our bodies healthy for eternity is still in the beginning stages. But what does this mean for us mere mortals who will never live to see the day when immortality is within reach? There is one chilling possibility that will give us all a chance to hang on, even after we die. We're all genetically programmed to lust for life and to flee from death. Eventually, we will discover the secret of immortality, but we're not there yet. To cheat death right now, we need to put aging on ice and be ready to grasp eternal life long after life abandons us. Greg Fahey is a cryobiologist. The goal of his team at biotech outfit 21st Century Medicine is to freeze human organs and tissues so that they can be revived undamaged centuries from now.
Cryopreservation is the preservation of living systems at very low temperatures. We usually are referring to temperatures that are low enough that you can store the system as long as you wish before you use it again. Cryopreservation is essential to get a cell or a tissue and organ from one place in time to another place in time without allowing that system to change in the process.
Scientists have been trying to preserve whole organs for decades. But it's a lot harder than throwing food in the freezer. When biological material freezes, ice crystals form, which push the cells out of their normal positions. When you thaw the organ, it may look okay from the outside, but on the inside, it's damaged beyond repair.
The biggest problem, we think, is really mechanical. It's the formation of ice between cells. If the cells are dislodged from their normal locations, then you can destroy the function of that structure as a whole, even if the cells survive.
Greg and his team decided to focus their efforts on preventing bodily fluids from freezing, and eventually developed a way to turn those fluids into a form of biological glass, a technique he calls vitrification.
Vitrification is the formation of a glass. So if you take water and you mix it with various chemicals in high enough concentrations of chemical, and then cool it down to low temperatures, the system will never freeze, no matter how low you go.
To test whether vitrification actually preserves the function of whole organs, Greg's team vitrified a rabbit kidney.
This is the kidney perfusion lab. What John is doing in the background is delivering